Okay, so this is a quick video reviewing these problems from Review A for the 9 weeks exam. Number 1, what is the solution to x squared equal 81? Oops. So we want to find out the value of x. So we're going to undo the square by taking the square root of both sides. Square root of a square are opposites, so they cancel. And the square root of 81 is 9. And we could do a positive 9 or a negative 9, so 9 is correct. Number 2, Ellen's math homework involves finding out how many solutions some equations have. So let's find out how many solutions each of these have. The first one, 5 times the group x plus 1 equal 25. Well, if we start solving this, we get 5x plus 5 equal 25. And I can tell now it'll have x equal a number, but I'm going to subtract 5 from both sides. I get 5x equal 20. Divide both sides by 5, and x is 4. So this has one solution. So I'm just going to go ahead and note one solution. Okay. For the next equation, 12 plus 3x plus 5 equal x plus 19 plus 2x minus 2. I'm going to combine like terms. On the left side, we have 12 plus 5. So we end up with 3x plus 17. On the right side, we have x plus 2x, which is 3x. And then 19 minus 2 is positive 17. So notice here that the left side is 3x plus 17, the right side is 3x plus 17. These are equal. This is true. And we end up with infinitely many solutions. The next equation, we have 4x equal 3 times the group x plus 4 minus 8. So on the left side, or right side, we have 3 times x, which is 3x, and 3 times 4, which is positive 12, minus 8. Now we're going to combine like terms on the right side. So we have 4x equal 3x, and then 12 minus 8 is positive 4. Now we're going to get rid of the fact that we have an x term on each side. We're going to get rid of 1, so I'm going to get rid of 3x. And what happens is we get x equal 4, which is one solution. And then last, we have this equation 2x plus 10 plus 6x equal 8x minus 7. We can combine like terms on the left side. 2x plus 6x is 8x. Bring down your plus 10. And then the right side, there's nothing we can do to simplify. And you'll probably notice that we have 8x and a number on each side, and the numbers are different. So if I look at those, I have an x term on each side. I'm going to get rid of one of them, which actually cancels out both. And we end up with a number equal a number, and it's false. That would be no solution. Number 3, what is the solution for x in this equation? So we're going to start with distributive property. 5 times x is 5x. 5 times negative 4 is negative 20. Equal 2 plus 3x. I'm going to get rid of one of these x terms. I've got 1 on each side of the equation, so I'm going to get rid of 3x. I end up with 2x minus 20 equal 2. And I'm going to rewrite it over here where I have space. So now I have a two-step equation. I'm going to box in my x term, which tells me I'm getting rid of this minus 20 by adding 20 to both sides of the equal sign. So we get 2x equal 22. Divide both sides by 2, and x is 11. Number 4, Jack is estimating the square root of 75. He says it's between 8 and 9. Brenda says it's between 8.6 and 8.7. And we're trying to get a good estimate. So between what two consecutive numbers does square root of 75 lie? Well, we're using a calculator, so we can just go directly to the calculator, type in square root of 75, and we get this decimal 8.6602 ... It keeps on going. And we want to estimate what two numbers it falls between to the hundredths place. Well, this is 8.6 something. So it's going to be between 8.66 and 8.67, which is answer choice D. Number 5, what's the solution to the equation? We're going to start with distributive property. Half of x is 1/2 x. Half of 5 is 2.5 or 2.5 equals 10. So now we just have a problem where we're going to get x by itself. So we've got a little two-step equation. We're going to get rid of 2.5 by subtracting 2.5 from both sides. We end up with 1/2 x equal 7.5. And I could multiply both sides by 2, or I could divide both sides by 1/2. I think I'm just going to divide by 1/2, though there's a couple ways to do that. In a calculator, though, if you said 1/2 x divided by 1/2, you get x. And in a calculator, you could say 7.5 divided by half, which is like multiplying by 2, and you get 15. And we got answer choice C. Number 6 you won't see on your test tomorrow or Wednesday on your non-mix exam, but just to get some idea, Aubrey crafted her own bird feeders and slowly added them to her yard. She recorded the number of feeders in her yard, X, and the number of birds that appeared, Y, in the graph below. What is the initial value of the number of birds that appeared in the graph below? Initial value is the y-intercept. So where did it start? At 3. And that's your answer. You will not be tested on this. So this is not tested this week. Number 7, we're finding what two numbers each of these fall between. So square root of 48, we go to a calculator, type in square root of 48, and I get 6.928. That's between 6 and 7. 2 pi, go to a calculator and I say 2 times pi, and I get 6.28. That's between 6 and 7. Go to a calculator for square root of 35. So square root of 35, it's 5.9 something. That's going to be between 5 and 6. And then square root of 20, I can go to a calculator and I get 4.4 something. That's between 4 and 5. And I should put ... after each of these because they were not exactly these values. They just kept on going, but we could tell what they fell between. Number 8, determine the rate of change of the function graph below. Okay, so when you see linear function, just remember this is just a line. It's talking about an equation. And rate of change is just another phrase for slope. This will not be tested this week using those terms, but slope will be tested. So we have a point here, 0, 1, and we have a point here, 2, 2. So we're going to use rise over run. And say, okay, it rises 1, and then it runs to the right 2, and right is going more positive. So the slope is 1/2. Number 9, which shows the approximate location of square root of 13. So we go to our calculator and type square root of 13, and we get 3.6 something. Well, 3.6 is between 3 and 4. That'd be right here, point B. Number 10 will not be tested, but it gives you an equation, y equal 12 plus 16x. Notice it's very similar to slope-intercept form, where y is the total amount of money Annie paid in dollars to the magazine company, and x is the number of magazines she received. How much does Annie pay for each additional magazine? It's asking for the slope, which is a rate of change, and that would be the number that's multiplied by x, which is 16. So she pays $16 for each additional magazine, but remember, this will not be tested. Okay, number 11, rational or irrational numbers. We can go to a calculator if we're not sure. Square root of 2, that is 1.414 ... Does not end, does not repeat, so it is irrational. 17 over 25 is a fraction. That's a ratio. It makes it rational because it has the word ratio in it. 3 times pi. Anytime you multiply or divide with pi, you're going to end up with an irrational number because pi is irrational. And you get 9.424 ... It does not end. It does not repeat. It is not rational. Now, 6.11111 is a terminating decimal. It's terminating. That means that it can be written as a fraction, so it is rational. Square root of 50 is a decimal, 7.071 ... It does not end. It does not repeat. So it is not rational. It's an irrational number. Number 12 will not be tested. Will not be tested. It says the equation represents the total profit in dollars that a business has accumulated after M months. By how much in dollars does the profit change each month? It's asking for a rate of change, which is just the slope. So this equation is in the form of y equal mx plus b, where the number that is times the variable is 1,340, and that's your answer. But it will not be tested on this 9 weeks exam. Number 13 asks if they are irrational. 13 is a fraction, so it can be written as a ratio, so it is rational. Negative 0.0028 is a repeating decimal, which can be written as a fraction, so it is rational. 3.5169 is a terminating decimal. It ends, so it can be written as a fraction. It is rational. Square root of 20 is a decimal value, 4.472 ... It just keeps on going. It does not end. It does not repeat. If it's a decimal that does not end and does not repeat, then it is irrational. 11 pi is a decimal, 34.557 ... It does not end. It does not repeat. So it is an irrational number. Number 14, Emily was given the equation 7 times the group 5x plus 5 equal 9 times the group 8x plus 7. And Emily simplified the left side, so let's go ahead and see what that comes out to. We use distributive property at 35x plus 63. And then she simplified the right side, 9 times 8x plus 7, used this distributive property to get 72x plus 63. We just multiply each term by 9, and we get that for choice 2. And then she determined the number of solutions the equation has. Well, just remember, when she simplified, we got this equation. And we've discussed before that if these x terms are different on each side, that when you solve, it's going to have one solution. So there will be one solution, so we can eliminate those two answer choices. So let's subtract 35x from both sides. We get 63 equal 37x plus 63. Subtract 63 from both sides to get the term that has x by itself. We get 0 equal 37x. Then divide both sides by 37 to get that 0 equal x. So we've got a solution of 0. Number 15, it gives us a student's work in solving an equation, and the first choice asks if it's correct or incorrect. I would start a problem like this by going ahead and just working the problem myself and seeing if it was the same. So we do distributive property. A ninth of 36x is 4x. A ninth of 72 is 8, equal 12x. 2 times 8x is 16x. 2 times negative 3 is negative 6. And this matches. Now I'm going to combine like terms. On the right side, we have 12x plus 16x, which is 28x. Then we have negative 6 plus 22, which is positive 16. So now we notice that these don't look the same at this step. So this student worked it incorrectly. And we can see the error was that the student must have said 12x minus 16x to get negative 4x. But we can go ahead and continue solving. I'm going to subtract 4x from both sides to get an x term on just one side. Then we subtract 16 from both sides to get negative 8 equal 24x. Divide both sides by 24. And we get that negative 1/3 is equal to x. And so this has one solution. Number 16, we're going to select all the equations that have no solution. Remember, we don't have to entirely solve these. We're going to get to the point where we have an x term on each side, and if they're the same, but the numbers are different, then it's no solution. So this first one, 5 plus 3x equal 3 times x is 3x, 3 times negative 10 is negative 30. So we will end up with 5 equal negative 30, so no solution. In this next equation, we've got 8x minus 17 equal 2x plus 8x, which is 10x. I'm going to tell you right here, since these x terms are different, this one will have one solution. In our next equation, we have 2x plus 7 equal 2 times x is 2x, 2 times negative 1 is negative 2, plus 9. These are like terms on the right side, so we have 2x plus 7 equal 2x plus 7. These are the same, so this is infinitely many solutions. Now we can inspect this fourth equation. We have an x term on the right side and an x term on the left side, but their signs are different. Signs are different. So this one is going to have one solution when we solve it. Then our last one here, I'm going to use distributive property to get 27 minus 18x equal, we have like terms on the right side, 2x minus 20x is negative 18x plus 12. So we end up, if we continue solving, although we could tell already that our x terms are the same, so our numbers are not the same, and we will have no solution.